Welcome, students. In this video, I'll be talking about how to understand proportions in scale drawings and similar figures. Please subscribe. Proportions are fundamental when working with scale drawings and similar figures. They allow us to create accurate representations of objects, ensuring that each part of the object is in the correct ratio to the whole. So the basic concept is each part of the object is in the correct ratio to the whole. This concept is widely used in fields such as architecture, engineering, and art. So what are scale drawings? Scale drawings are representations of objects or structures that maintain the correct proportions by either reduce or enlarge in size. They are used to give a clear picture of how an object would look in real life while fitting it onto a manageable size of paper or digital format. So they can be used for objects or structures, used for objects or structures. And what are similar figures? Similar figures are shapes that have the same form but differ in size. So similar figures are shapes that have the same form but differ in size. So corresponding angles are equal. But size are proportional. So let me give you one example of a scale drawing. Example 1, scale drawing. So let's say you have a building, a building model with scale of 1 to 100. That means how, so let's say the building, and then we're gonna ask, the building is 200 units. What would be the drone measurement? So for that, we can say that since unit, uh, so 1/100, that will be, and then actual, and then will be model. That means that the actual is 200. So we want to find the model. So model will be here, model. So all I need to do is multiply both sides by 200. And then model will be 200/100. Then we cancel zeros, and that will be 2/1, which is equal to 2. So the measurement will be 2. Now let's do geometric similar figures. Let's do similar figures examples. Let's do example 1. Triangle. So we have triangle A and triangle B. So let's draw two triangles. So this will be triangle A and this will be triangle B. You say this is 90 degrees, 90 degrees. So let's say this is 6. 6. Or let's do 6 here. A here and 10 here. Let's do 3, 4, and 5. So to see if these triangles are proportional, then we need to compare each side ratio. Side ratio to the whole. Again. So we're gonna do is 4/8 because 4 here and 8 here corresponding sides. And then we're gonna do 3 and 6, 3/6, and then we do 5/10. 5, 10. Now let's simplify. 4 divided by 8, that we divide top and bottom by 4 because that's the highest we can divide by. And we're gonna get 1/2. We can divide top and bottom by 3. And we're gonna get 1/2. Top and bottom by 5. And we're gonna get 1/2. That means that if you notice 1/2, 1/2, and 1/2, that means that so we have all corresponding sides. So all corresponding side length ratio are equal. That means that triangle A and B are similar. So are they proportional? Yes. Now we're going to do example 2. Rectangle. So let's see. Rectangle, all angles are the same, so they're all 90 degrees. We're going to say rectangle X and rectangle Y. You can say this one is 12 and 6. This one is 24 and 12. That means we need to check for similarity. Okay, similar. So then we say, so corresponding side 6 and 12, that will be 6 over 12, and we'll do the other one, 12 and 24. So let's divide top and bottom by 6. And divide by 6. So that's equal to 6 over 6 is 1. Over 12 divided by 6 is 2. And then top and bottom by 12 divided, and we'll get 1 over 2. So both ratios, ratios are equal. That means rectangle A and rectangles A and B, and I'm sorry, not A and B this time, X and Y are similar. Let's do the last example. Example 3. Parallelograms. So consider 2 parallelograms, Parallelogram M and N. So M size are 5 centimeters and 9 centimeters. And parallelogram N sides are 10 centimeters and 18 centimeters. Okay, so let's compare side by side. So 5 and 10, so shorter side, okay. We're gonna do short side. It's 5 over 10. And long side is 9 over 18. So let's divide top and bottom by 5. By 5. That's 5 over 5 is 1. 10 over 5, that's 2. And let's divide top and bottom by 9 for the long side. And that will be equal to 1 over 2. So both ratios are 1/2. That means that Parallelograms M and N are similar. So these examples illustrate how to check for proportionality in similar figures and in similar objects by comparing the ratios of corresponding size or 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 scales. So this concept is crucial for accurate analysis and applications in various geometric contexts. Thank you for watching. Please subscribe.